Welcome to Test 3 review. We had a request for Fall 21. Test 3, Part 4. Question 2, the mechanism. Circle the major product form in the following reaction. I actually don't circle them until I do the mechanism, because the mechanism helps me remember what the major product is. And then I'm going to explain, and I'm going to do a discussion of regio and stereoselectivity during my explanation. And then I'm going to do a mechanism for the formation of the major product and the final product in the last step. So when we see a D in this class, D is deuterium. Is a heavy isotope of hydrogen. Same chemistry as hydrogen. But you put a D instead of H as the label. That's the whole story with isotopes. And isotopes help us figure out mechanism. All this work was done before. And we're just testing you to see if you remember the results. So I have to remember ionization of the mercury acetate is the first step in this mechanism. And the ionization creates a mercury cation. That's why the electrons went away from mercury. So we get a mercury cation. Mercury cations love alkenes. OAC is a good short form. ACO minus is a good short form for the thing on the right. And it's the conjugate base of acetic acid. Remember that. Pi electrons attack the mercury cation, one arrow only, and you generate a cyclic mercurinium ion that looks like this. Partial bonds all the way around in a triangle. 3 partial bonds. Still has an OAC. The cation is now shared in the middle of the triangle. Okay. And triangles always follow, the step after the making the triangle is always what kind of reaction? Backside attack using water. And which atom do you attack in the triangle? The more substituted, thank you. That's this one with the methyl on it. And that arrow was a little lame. Here we go. Right to the carbon. One arrow there, that's it. So right away, I'm getting rid of this product where the mercury is on the more substituted carbon, and this one where the mercury is on the more substituted carbon. And the backside attack on a triangle, does that produce syn or anti-stereoselectivity? Anti, so I'm only looking at the third product. This one has syn. That's wrong. Syn is wrong. Anti is right. And you don't quite get that product just yet because your water has 2 H's on the O. We are close. We are close. We've got the OH on the more substituted carbon. And it was black, why not? We need a little more room underneath there. And the other carbon has the mercury. Right there. And how do you make that into our circled product? What base do you use to take the proton off of the oxonium? The acetate, that's correct. I got acetate up there. could cross the arrows. That's dangerous. Go with a pink arrow. There you go. So we know that that's a pink one. Grabs the H. Get acetic acid. Don't have to show acetic acid. I'm not even going to write it. Okay. So not a bad mechanism. And what is NABD4 going to do? Well, you copy everything. Remember, the step's called demercuration. Copy everything except the mercury. Okay, let's do that. Copy everything except the mercury. And the OH is here. Methyl's here. What goes in the place of the mercury on the wedge? Hydrogen, but in this case, we don't have hydrogen, but we have a chemical that's equivalent to hydrogen, D. Put D there. If it was NABH4, you'd put an H there, but then I wouldn't know that you knew this one fact. The D goes exactly where the mercury was, and if there was an H here, then you'd have two H's. I wouldn't even be able to grade wedge or dash because there's two H's on that carbon. But by using D, there's only one, and one's a D. And yeah, so I want you to know the D goes exactly where the mercury was. Okay? And we're going to do some explaining. We did a circle. We didn't explain our choice, but we're going to do both the regioselectivity, because it happened right here. We'll do explanations in green. Regioselectivity equals Markovnikov. You don't get anything really for that, but you do when you explain, because water attacked which carbon? There you go. That's why the O ended up there. More substituted C. And why? Because that C spends more time with a plus charge. And I want to know why. Big word. Ends with ION. That's the magic big word. Oh, there you go. Hyperconjugation. Yeah. So the explain was pretty big there for B. That's regio only. Wow. What about B, stereoselectivity? Yeah, that's what I want to hear. That's a much shorter answer. Backside attack gives anti-stereoselectivity. Backside attack, every time you can just write an arrow and say anti. Done. Good. That's a good one. It's got a lot of good stuff going on there. Final, give the result for the reaction. I think we've got all the loose parts that we need. And we're stopping.